Hi, my name is Daniel Gottschall. I'm with the Mathematics Learning Resource Center, and this is my second video on the equation of an ellipse. Okay, so my first video talked about abstractly what the equation of an ellipse looks like and how to graph it using general coordinates. So here I just want to do a couple concrete examples on that. So you can see here where I drew the graph of an ellipse centered at 2, comma 1 with those 4 points. Uh, Again, if you look back at the last video, you'll see in general where we're guaranteed 4 points. Actually, I have it drawn right here if you need a quick refresher. Uh, there's the left, right, top, bottom 4 points that we can always get. So here I just put some concrete numbers in for that. Okay, so let's say you have this picture and I ask you for the equation of this ellipse. How do we get that? Well, I drew the general equation up here, and of course we're going to leave x and y alone, but we need to fill in the h, k, a, and b. Uh, so the easiest ones to get are typically the hk. Here I actually drew what the center was, 2, comma 1, so clearly that's our h and k. If I didn't show you what this was, you can easily find the center as simply counting from the left and from the right and finding the midpoint between those. Same with the top and bottom, finding the y coordinate that's halfway between those. So you can do that. Uh, and actually, you can do this by even instead of counting. So let's say if we wanted to find the x coordinate, I could add the 2 here. So that 6 minus 2 is 4, and then you divide it by 2. That gives me the 2 here. Similarly with the y coordinates, I could add the 4 and negative 2 to get 2. And then 2 divided by 2 is the 1 that we get there, if I didn't write that. So either way, we know that our h is 2 and our k is 1, so let's fill that in. Okay, and then I need to know next what my a squared looks like. Uh, we'll look back as a refresher from the previous video where we have the right point here being h plus a comma 0. Uh, and we know that our h is 2. So we know here what I'm saying is this is 6 has to be h plus a. And we know that h is 2, so that tells us a is 4. So I fill that in, 4 squared. Similarly with our b, we go back to our abstract drawing. I have the top point being h comma k plus b. So looking at the y coordinate, I know that 4 has to be k plus b. And we said that we said that k is 1. So 4 is 1 plus b is 3. Fill that in. And that's all we need because x and y are only 2 variables as desired for a concrete equation. So that would be our answer. So it's not too bad, I hope, going from the graph to the equation. Now the rest of this video, I'm going to talk about going the other direction. How do we go from an equation like this one? I'm telling you it's an ellipse, but that's not at all clear right now just looking at it. How would we possibly get the graph from an equation that looks like this? Well, we have to make it look like a general form. I won't bother writing it again. Hopefully you remember, we first have to group the x terms. Actually, I'll scroll up to quickly glance at it. So we have x minus h squared, y minus k squared. So we need to group our x and y terms together. So we have x minus something squared and y minus something squared. So let's do that. So actually, I already put the x terms next to each other and the y terms together. So then our next step, uh, it may not be immediately queer y, but it's always good to factor out something if you can. So notice here I can factor out a 25. You could potentially skip this and jump to the step I'll do next, but it just makes it easier if you factor first, just so you're dealing with smaller numbers. So I have x squared minus 6x. And then with the y's, I can factor out a 4. Okay, now what do we do? Well, remember, I want to write this as x minus h squared. So if you look at this, you can see, you may remember from hopefully with quadrilaterals that, of course, we're going to have x here as our term. And then, so when we have something like x minus c squared, as a side note, this comes out to be x squared minus 2cx plus c squared. And so we essentially see that the middle term, or the x term, I should say, is doubled. So if we want to get negative 6x, we need to pick c equals 3 clearly. So that way our x term will come out to minus 2 times 3x, or minus 6x, as we have up here. But then if we do that, we also have this c squared term to deal with. So here it would be plus 9. We actually have to be careful. It's plus 9 inside the 25. So we need to deal with that because that wasn't, we can't just add something that wasn't there unless we cancel it out, so we're not changing the equation. So if we have a plus 9 inside, then we need to subtract, we could think of it as 25 times 9. So let me just write it like that for now. Oops, let me use black ink. Right, because what I'm saying is we'll have an extra plus 9 term when we square this, but then we're multiplying the whole thing by 25. So if I want to undo that, I have to subtract 9 times 25. Hopefully that's clear. And then we're going to use a similar tactic for the y's. So if I want to square what I have inside, just pretend that's a minus 2cy term. I clearly need c to be 4. Right, because then that will give me minus 2 times 4y, or minus 8y, as we have up here. But now again, we're going to have this plus c squared, which here would be plus 4 squared, or plus 16. And then that plus 16 will also multiply by 4. So if I want to undo that effect, I have to subtract the minus 4 times the 16. All right, and then I'm left over for plus 189 equals 0. All right, now what do we do? Well, we have x minus something squared, y minus something squared. That's excellent. Now we just need to, the next step typically is to move all the constants to the right side. Because if you look back up at a general form box there, it's just x minus h squared plus y minus k squared. You don't see any constant terms on the left. So let's do that. So I'm only going to keep these terms on the left. And then, okay, so I move everything over. So this is plus, and I'm also going to multiply. So 25 times 9 is actually 225. 4 times 16 is 64. And then I move the 189, which becomes negative, moving to the right side. All right, and let's just simplify that quickly. And if you do the math, that comes out to plus 100. All right, so now this is looking more like our typical ellipse equation. What do we have to do here? Well, we probably want to divide by the 100, right? So we just have 1 on the right, as our general form up top suggests. So let's do that. Divide everything by 100, which we're allowed to do. That doesn't change the equation. All right, so 25 over 100, that's just 1 over 4 if I do the reduction. Sorry, and then we have to 4 over 100 is 25 on the bottom. Alright, so we're very close now. We can see it almost looks like an ellipse. The only thing is, keep in mind of our general form, we have a squared and b squared, not just a and b in the bottom. So let's address that. So 4 is clearly 2 squared. And then the 25 is, of course, going to be 5 squared. Alright, this is the form we want to graph the ellipse. Now let's just quickly sketch the graph to make sure, I guess, to finish the problem and just to see how this works. So general form, x minus h, y minus k. So we can see here that my h is 3, my y is 4. Be careful with the signs here. It's x minus h, so it's x minus 3, meaning h is positive 3, and same with the 4. And then we also know that my a is 2, my b is 5. So if we do that, I'm actually going to save space too. I'm going to make these 2s, so let's do this 2, 4, 6, 8, just to save on space. I'm not sure exactly how much room I need here. Alright, so I know my center's at 3, comma 4. I know that my A is 2, so my right point is h plus A, so I have 3 plus 2, or 5. As h minus A similarly is 1, and then I have my B is h comma B plus K, and I know my K is 4. So my top point, B plus K, is going to be 4 plus 5, or 9. Okay, so I need one more tick mark. And similarly, K minus B would be negative 1. Oops, sorry, I messed up the x coordinates on those vertical points. That should be here and here. So my ellipse looks something roughly like that. So I'm not a great drawer, but hopefully you see what I'm getting at. So that would be the rough graph of that ellipse. So anyway, I hope that helps you to understand more concretely how to go from graphs to functions and vice versa. I am going to do another video on the equations of ellipses, but that one's going to talk more about other features, namely the foci points that every ellipse has, as well as the eccentricity, perhaps I'll get to. So yeah, if you're not familiar with those, please watch that one. As always, hope that these videos are helping. Thanks for watching. Bye.